Okay, let's go over problems A and B for round 705 division 2. I spent too long on the second question, so I didn't have time to solve any of the other ones, so sorry about that. So problem A is you're given two integers, n and k. You're asked to choose a maximum number of distinct integers from 1 through n so that there is no subset of chosen numbers with sum equal to k. Let's actually write out an example and things kind of follow from there. So let's say n is 10 and k is 7, and let's list out all the numbers from 1 through 10. So the first thing to notice is that you can just choose every number greater than k, right? There's no way they're going to add up to k, right? The next thing to notice is that you cannot choose 7, right? Like if you choose 7, then it's GG already, because like you can just pick the subset 7 and that has sum 7. So you definitely cannot pick k, right? And so now you're kind of in this region from 1 through k minus 1. And so basically, how should you do this? The thing to notice, right, is that if you start from the beginning, right, like let's say you start from 1 to 3 and 4 and so on, like it's kind of a bad idea, right? So let's say that k is 6 and you start doing for 1, 2, and 3. Like even though no pairs of numbers add up to 6, the sum 1, 2, 3 is equal to 6, right? And so if you start from the beginning doing this, you kind of end up having to keep track of like all the possible sums along every subset that you've seen. So instead, let's kind of start from the end. And in general, let's go back from 6, 5, 4, and then let's just go back from 6, 5, 4. Can we add 3? No, we can't because we already added 4. And so in general, you'll notice that we can start from the back of this range and just keep adding numbers until we get to the ceiling of n, k over 2. And in general, this always works because all of these numbers are greater than n over 2, and we don't have to kind of like keep track of subset sums and everything, because everything is greater than n over 2, so their sums are always greater than, everything's greater than k over 2, so their sums are always greater than k, and so we kind of are guaranteed that none of them have sum equal to k. And so in general, this is kind of the optimal strategy. So like before k, we just pick numbers from ceiling of k over 2 to k minus 1. And in general, like you can prove this is you can kind of prove this is optimal, right? Because you can kind of prove this is optimal because like you can't add anything on the left because you already added its corresponding pair on the right. So like for example, 3 plus 4 is equal to 7, right? But we've already added 4. 2 plus 5 is equal to 7. We've added 5, right? And so basically we're just we're only constraining ourselves to like pairs of 2 rather than like sets of 3 or sets of 4 and sets of arbitrary size. So that's kind of the reason why this is optimal. So just to recap, the way you do this problem is basically you first choose all the numbers greater than k, and then you pick all the numbers from ceiling of k over 2 to k minus 1. And I can show you my code for this. I did it I can put it over here. Basically, I made it so that my result is in sorted order. So first I picked numbers from ceiling of k over 2 to k, and then I picked everything greater than k to n. Cool. Let's go on to the second question. I spent a little too long on this question trying to come up with a clever way of doing this, but this is actually kind of a brute force question. And so basically, the question statement is that you're given two integers h and m, and basically like you have a clock, and then the hours are numbered from 0 to h minus 1, and the minutes are numbered from 0 to m minus 1. And like this clock is like a physical clock, so like these, it has digits which look like this, and you're given the time, and you want to find the closest time in the future such that the like if you look in the mirror, the clock still shows a valid time. And the definition of a valid time is that all the numbers are valid, and the current hour and the current minute is less than h and less than m, respectively. And so yeah, basically the question kind of requires you to think about what this rotation means. And what a rotation means is that basically if you have a time like this, what a rotation is that the most significant digit of the hour becomes the least significant digit of the minute, and vice versa, and the least significant digit of the hour becomes the most significant digit of the minute, and vice versa. Also, what a rotation means is that if you have a number, right? I'm just going to list out all the numbers, all the digits from 0 to 9. So like there's only certain digits which have a valid. Sorry, did I say rotation? I meant reflection. There's only certain digits which have a valid reflection, and these are 0, which you can reflect to get 0, 1, which you can reflect to get 2, 2, which you can reflect to get 5. Like the way I wrote them, it doesn't look like it, but this picture, like if you look at this picture, if you reflect 2 across the middle line, you get 5, right? Yeah, so 5 you can reflect to 2, you can't do anything in 3 and 4. 8 you can reflect to 8, and that's it. And so basically these two pieces of information are all that you need. And what you do then is, like, say you're given like h is 60, m is 60, and you're given like 55, 30, right? Basically what you do is for every time you check to see if it has a valid rotation, right? And yeah, so here 55, 30 definitely does not have a valid rotation because 3 does not have a valid rotation, right? So you just keep adding 1 and checking, adding 1, checking, adding 1, checking until you get to a number which does have a valid rotation, which in this case is, I think that number is going to be 55, 50, right? And I just want to spend some time talking about what a valid reflection actually is. And so, like the way you check if this thing is a valid reflection is basically you just do this swapping thing. So this becomes 0, 5, 5, 5, right? And then the second part is like you have to do these rotations. Sorry, sorry. You have to do this reflection in the map. So 5 becomes 2 basically, and then so this is part 1, kind of like flip. Part 2, which is map, and then there's a third part which is important not to forget, which is you have to check less than h and less than m, right? So in order for this to be a valid time, that the hours needs to be less than h, and then the minutes needs to be less than m. In this case, it's that check passes, but you can easily imagine a case where like the first 2 checks pass, but the third one doesn't, and you have to be careful. And so yeah, that's basically the way to do this problem. You just keep adding 1 to the time you have until you you get to a valid time, and then you just do the check each time. Yeah, and when I saw this problem, I was trying to do something clever where I would look at each digit starting from the left, but there were just too many edge cases there. So like this brute force is the easiest way to do this problem, I think. And so finally, let me just show you my code. It's here. Yeah, so I have this map. This map corresponds to this thing. And so basically, I start from the current hour and current time, doing some string parsing to get them, and then I literally have a while true loop, and then for like while true, I increment the minute and hour necessary, and then I check, and then yeah, this check basically does these three steps, right? So this is the or like I do step two before step one, but whatever. And then yeah, so I get the hour and minute for the solution, and then I do some string processing to make them um, like to display them. And the important thing to like an implementation detail with string processing is that like sometimes H&M can be like single digit instead of double digit. So if it's a single digit, you just have to make the most significant digit zero. Yeah, thanks for watching.